Hello and welcome to my YouTube channel on data analysis and research. Today we want to look at interaction. So in data analysis, especially in regression, you might want to see whether there's interaction between two independent variables on a dependent variable. So that is to say, we want to find out if the relationship between a dependent and a predictor variable varies between the subgroups of a third variable, so another independent variable. So in that case, there will be differences in subgroups of the third variable of the relationship between the dependent and the independent variable. So in this case, let's say we have predictor independent variable 1 and then 2, and then we have a dependent variable. So the relationship between the dependent variable and the independent variable 1 varies between the subgroups of the third variable, so the independent variable 2. So let's say the third variable have two groups, let's say controls and then cases. So the relationship between the dependent variable and the predictor variable 1 is different when you analyze it in the control group and then you do that in the among the cases. So that is interaction. So it's a form of subgroup analysis, or what we call, or it could be effect modification. So a third variable modifies the relationship between dependent and the independent variable. So that is interaction. To do interaction analysis in SPSS, there are various ways it can be done, and then we have also different types of interaction terms. So we have a two-way interaction. If we have two independent variables, it's two-way, and also the levels matter. You can have an independent variable with 3 levels, and then you can also have one with 2 levels or 4. The more the levels and the more the variables, the more complex the interpretation becomes. So the simplest ones are, you have two independent variables and they have 2 levels, so 0 and 1, coded 0 and 1. So that is very easy to interpret. So 0 and 1, that is for a categorical variable. However, you can also have interaction term between a categorical and a continuous variable, or between two continuous variables. So in that case, the way it is done is different. So in another video, I will demonstrate how to create an interaction term between a categorical and continuous variable, or between two continuous variables. There's a step you have to perform called the mean centering. So you center the variable on its mean to reduce multi-collinearity. So that is for if there's a continuous variable in the term. But in this case, if you look at this model, we are looking at preeclampsia, then periodontal disease. We want to see if the relationship with total cholesterol varies by the third variable. So that is the interaction term PE times PD. So how do you create this term? This is a two-way interaction term. So how do you create this in SPSS? So this is our data set, and then you can see our PE, that's preeclampsia, is coded 0 and 1. Okay, so cases and control. And then among them, in the population of the preeclampsia, we also detected some having periodontal disease. So it's also coded 0, 1. So we now want to create an interaction term. In SPSS, to create the interaction term, you need to go to transform, then you say compute. Okay, so let me reset this. So compute, so this is PE. So if you want, you can use times PD. So that is interaction. Then we move our P variable here. So multiply by, select the asterisk sign, multiply by PD. Okay, then we create. So we click OK. So the variable is created. So let's go and see whether it is created. So we come here first, variable view. So this is our PE times PD. Let's reduce this to 0 decimal because it's categorical. Then let's check our data view to see whether our variable is there. So you can see this variable. So you see that it's 0 and 1. It's 0 and 1 because the predictor values were all coded 0 and then 1. So how do you now model to see whether there's significant interaction between the two on the dependent variable? So go to regression, then we select linear because our dependent variable is linear, total cholesterol. So we come here, so you move your total cholesterol dependent variable to the dependent variable cell. So interaction, you just don't move only the interaction term into your independent variable box. You have to add the variables first, and then you add the interaction term because you want to see what the relationship is to the dependent variable individually, and now when combined, you want to see whether uh, there's interaction. So if sometimes if there are other variables that are confounding variables, they can be added to the model. So let's say BMI was significant difference between the cases and the controls. You can add it here because it could confound the results. You could add it to adjust for any differences. So here we will not, we'll just leave this and then see how the results will be. So for statistics, you might want the confidence interval. We add it. This is multi-variable linear regression or regression. You might have to test for assumptions. There are some assumptions of regression, linear regression that you have to test, multivariable linear regression. So collinearity is one of them. We have the homoscedasticity, it's also another one. Then we have the multivariable normality. So that is another. So I will select them, but we will not discuss them. I will look at them in another video. But they are very important if your model, if you want your model to be accurate, they must not violate these assumptions. Okay, you might also want to plot. So this is the predicted value on the y-axis, the residuals on the x. Okay, and then you select normality, normal probability plot. Okay, so these are the assumptions you want to test for the model. Then you go to OK. So let's see what we get. So these are the summary, then the ANOVA statistics, but this is our model. So you can see the constant, then the beta values, the p-value, and then it's a 95% confidence interval. Then let's look at the individual. So these are preeclampsia. If you check the p-value, it is not significant. Periodontal disease is also not significant. but their interaction. So it means that uh, their relationship is different uh, within the subgroups of the independent variables. So on their own, you might see that they are not significant, but it means that among pregnant women with preeclampsia, the relationship between periodontal disease and total cholesterol is different from those who have preeclampsia. So that means the subgroups have different relationship with the dependent variable. So you can see it is significant here. So that's the significance here. Okay. Alright. So this is how it is done. For the assumptions, you can see the variance inflation factor here. That is for multicollinearity. And then for it is recommended that this value should not be higher than 5. So all of them are less than 5, meaning that there is no multicollinearity here. Okay. Then this is a normality plot. So at least the model is the residuals are normally distributed. You can see that it's almost linear following the line here. And then this for homoscedasticity. So here you can fit a line, the loose, you fit to see whether uh, your residuals are there's homogeneity. So for it, you see that it is not. The distribution of the data set should be almost equal below and above the line, below and above. But you can see that it is not so. So this model may have violated the homogeneity test, or what we call the homoscedasticity. So that's hetero. You can see that there's heteroscedasticity in this model. So that means that you might have to look at a different approach to analyze, maybe using robust techniques or generalized linear modeling or another form of regression that will take care of this violation. So that is how we perform the interactions in a linear regression model in SPSS. So thank you for watching. Look forward to my next video on more interaction analysis. Bye for now.